Welcome to India's most comprehensive e-learning platform, BYJU'S Exam Prep. In this great evening, we all have gathered together to discuss one of the very important topic in industrial instrumentation, that is level as well as pressure measurement. Of course, currently we are being in the champion series discussion. Once again, yes. Currently we are in the champion series. Of course, we have done with a lot many subjects up to now, and we are discussing about industrial instrumentation and different important topics in industrial instrumentation and the questions related to industrial instrumentation in this particular lecture series. However, we have already done with the flow measurement and resistive transducers and even the capacitive transducers, and it is a high time to discuss one more important topic, that is level as well as pressure measurement. Those students who are very sincere and serious about the GATE preparation, especially from the instrumentation stream, they all know that level and pressure measurement is equally very important like flow measurement. So let us take some of the questions which are very important, in fact which will cover the majority of the concepts in the level and pressure measurement, so that you will really understand and converge to the better concepts. Clear? Moving ahead, before discussing the concepts related to the level and pressure measurement, let me quickly introduce about myself to the new students. All you can see here, myself Phanindra, all put together I have an experience of 12 plus years guiding ESC aspirants as well as GATE aspirants. Up to now, I have guided more than 50,000 students in the subjects of control systems, measurements, industrial instrumentation. Of course, I am specially known for industrial instrumentation. So this is a very simple introduction about myself. Good evening, Rajshekhar. Very good evening. Right? So moving ahead, this is the schedule what we have followed so far. Of course, we have done with the resistive transducers almost on the 3rd of October, that is at 9 p.m. and after that we have done with the capacitive transducers and flow measurement. These 3 sessions were already done. Those students who are very interested to go through these concepts, you can view in the playlist of the BYJU'S Exam Prep, and in case if you want to connect to me through the Telegram channel, you can use these credentials to get connected to me through the Telegram channel. However, in this lecture, as I mentioned, we will be mainly focusing on level and pressure measurement. And I would like to mention here, there are very few students who are working on the homework and giving the answers in the comment section. Let me tell you, those sincere students should be definitely appreciated at the end of the GATE examination. Clear? So moving ahead, let me discuss the statement of the first question here. Of course, as I said, level and pressure measurement is the topic of the day, and the statement of the first question is given like this. When you read the questions, especially in industrial instrumentation, you feel that the length of the question is so big. Yes, of course, length of the question is so big, but what is more important is it is not the length of the question, it is the depth of the question. Sometimes it may be possible to get a very tricky question in just 2 to 3 lines, but sometimes it may be possible to get a very easy question in 10 to 15 lines. So what all you have to see is, never try to estimate the strength of the question by seeing the length of the question. You have to estimate the strength of the question by seeing the depth of the question. Clear? So the first question is, in fact, the statement of the first question is, an ultrasonic sensor was used as a contactless water level sensor. So please see this statement. So ultrasonic sensor can be called as a contactless water level measurement sensor. Well, it is shown in the figure. Of course, the figure is very beautifully drawn here. The sensor was placed at 2 meters above the top surface of a tank. So that means from the top of the tank, it is almost at 2 meters above. Clear? So if the time taken from the emission to reception of the, see, please note down these statements, very important. In fact, even if you are sitting in the interview hall, this is the way how you should narrate the entire story of the ultrasonic level transmitter, in fact level measurement. So emission to reception of the sound wave when the tank is empty is 16,000 microseconds. See, this is when the tank is empty. What is more important up to now is this word like empty here. So that means when the tank is empty, it is all the way giving 16,000 microseconds it is taking for the light to travel from the source to transmitter to the bottom of the tank, and again from the bottom of the tank to the receiver. I will explain all these things, don't worry about anything, okay? Just be with me till the end, right? And the sound wave is having the velocity of 340 meters per second. Good. Calculate the height of the water level in centimeter. So in fact, let me tell you, instead of 10 centimeter, let me give it is in the meters. Okay, right, because it is in meters. So let me take this is also in meters. In the tank, if the flight time of the sensor's wave from the emission to reception is 13600 microsecond. These questions, especially in the recent time GATE questions, these questions became so popular. However, being an instrumentation engineer, when you are preparing for GATE examination, you cannot exclude the concept of ultrasonic flow, level measurement, isn't it? Let me explain the working of ultrasonic flow meter, level measurement here, along with the statement of the question, so that both will be completed to you, right? So first of all, case 1. So let me take case 1 here. So what is case 1 here? Case 1 is when tank is empty. Clear? So when tank is empty, so let me write down tank is empty. So tank is empty means probably there is no water in the tank, correct? So at that time, what will going to happen? We are having an ultrasonic transmitter and receiver, both are combined here. So let me write down, this is the transmitter and receiver, both are present there itself. What happens is ultrasonic transmitter, of course the ultrasonic means the frequency of the sound wave is very high, correct? That's why it is mentioned as ultrasonic, right? So it will generate a wave. So let us assume that this is the top surface of the tank. So let us assume that this is the top surface. Let me write down, this is the top surface. As it was mentioned in the statement of the question, let me call this as a top surface. Every one of you can see, I guess, right? So this is the top surface, and from the top surface to this particular sensor, we are having, this particular setup, we are having 2 meter height. This is a very, very important statement in the question, because many students, they will not understand that first of all. So the transmitter and receiver setup itself, it is around 2 meters height from the top surface of the tank. Clear? However, we don't know what is the length of this tank. So let us say the length of this tank, or we can say the height of the tank, whatever it may be, that is up to you. So let us take the total length of this tank is L here. Clear? The total length of the tank is L. So what was given in case 1, when the tank is empty, obviously the overall ultrasonic sound, what it will happen from the transmitter, it will all the way, it will come here. And when there is no water inside the tank, assume that there is no water inside the tank. When there is no water inside the tank, this is the way how the light will be transmitted here, correct? So it will hit this one, right? And once it is hitting at the bottom, then again it will be reflected back, correct? So assume that this is the way how it is getting reflected, and it will be reflected back, reflected back, reflected back, all the way it will reach to the receiver here. Clear? Now the simple question to you is, when the tank is empty, the ultrasound or ultrasonic wave, all the way it starts its journey from the transmitter to bottom of the tank. So let me call this as the bottom here. So this is bottom of tank. Clear? So obviously it will come up to the bottom of the tank when there is no liquid or there is no water, and again from the bottom it will be reached to the receiver. It's very simple to understand, no kacha bacha here, it's very easy, right? Now the question is, what is the overall time of journey here? So I can say the time of emission, that means time of emission, let me write down TE here. So what is the value of time of emission here? Any one of you? Time of emission means from transmitter to the bottom of the tank. So this can be clearly written as, that is 2 meters plus L. This is the distance, L is 2 meter, and L is going to be the total length of the tank here, and 2 meter is the distance from the top surface to the transmitter, correct? So therefore I can say the total distance here is going to be L plus 2, of course it is in a meter, right? So whole divided by the velocity of the light or speed of the light or speed of the wave. I'm extremely sorry, it is a sound wave. So speed of the sound wave is 340 meters per second, correct? So let me write down this as a 340 meters per second. So this is exactly the emission time. What will be the reception time now? Reception time, so that means the time taken for the wave to receive from the bottom of the tank again back to the receiver. Can you tell me what is the value of this one? Again the same length it will go into, same distance it will go into travel with the same velocity, because there is no liquid at all, right? So therefore again the same distance it will go into travel. So I can say L plus 2 divided by 340. This is distance by velocity, that will be equal to time. So now overall time will be what? So they have mentioned clearly that TE plus TR. Anyone who has a common sense, you can directly write down this as a 2 into L plus 2 divided by 340, and they have mentioned clearly that this particular time is equal to 1600 microseconds. Don't get misleaded by the statement of the question. This is wonderful statement. 16,000 microseconds. Well, so let me write down here 16,000 microseconds. So therefore 10 power minus 6 will be there. So if you rearrange all these things, what you will going to get here? So of course you will be getting like L plus 2, that will be equal to 170 into 16,000. Of course there will be 10 power minus 6 here. From this, if you rearrange, then L value will be equal to how much? Just calculate very fast here. So it's very easy. In fact, 170 into 16,000 here. So it's a big value, I know, right? It will be coming around, yes, 2.72, right? So 2.72 minus 2, because you have to take this 2 to this side. So obviously it will be in meter. So therefore I can say L is equal to 0.72 meter. So that means the overall tank height is 0.72 meter. This is a catch here. So I hope you understood this value. That is total length here. In fact, the total height of the tank is equal to 0.72 meter. Up to here it is very easy question. Because if you know the basics, then everything is cakewalk to you, right? Now let us see the case 2 here. Case 2 is interesting. So let me write down case 2 here. So let me say case 2. So case 2, when the tank is not empty, right? So that means there is some liquid here. When tank is not empty, clear? So not empty. So now can you please look at the statement and can you work out this and let me know the answer? I will be very happy if any one of you give the answer. That means, let us say there is some amount of the height that is there, or some amount of the liquid is present inside the tank. And maybe the liquid level, we can say, for example, we can consider the liquid level here in this particular case as H here. So let us say, so H is being the total, height here. Clear? So that is what we need to calculate. However, we don't know what is this particular value. So let me say this as a L minus H, or we can simply call this as X. Both will be same, right? We can call this as X. Now, in the second case, when the water is up to here, this can be considered as the top surface of the water here. So what will happen when the ultrasound wave comes from the transmitter? Obviously, it will hit the surface of the water and again it will be rebounced. That means on the surface of the water, it will hit and again it will come back or reflected back to the receiver. Clear? So such an interesting story, is it, right? So that means it will be reflected back to the receiver all the way like this here. Now if you see what is the overall distance it is covering here, it is covering 2 meter plus X, correct? So that means 2 plus X is going to be the distance it is covering here, and in the return also it is the same distance. Therefore in this particular case, what should I say here? So the total TE plus T, or that means emission plus reflection, now it could be written all the way as a 2 into, what should I say here? The 2 meter plus X here, correct? 2 meter plus X. Of course, this is going to be 340 here, and its value is given. If you look at in the previous statement, it is equal to 13,600, correct? So 13,600. So what will going to happen here? Now let me use this one, 13,600 microseconds. So that will be 10 power minus 6 here. From this, can you calculate what is the value of X here? Simple here. So again, 13600. So there will be some value 13600 into 170, of course, and you will be having 2.31 into 2.31, right? So in fact it is 2.31, right? 2.31 minus 2. So that means all the way the value of X here will be equal to 0.31 meter here. Clear? 0.31 meter. Excellent. So 0.31 meter is your what? The X value. So that means be clear about the total logic here, because unless until you are very good with the mathematics, you cannot do these things. Of course, L is going to be 0.72 meter. So let me take another color here. Yes, L is going to be 0.72 meter, as I was saying at the starting of the lecture here. L is 0.72 meter. What is the value of X? After a lot of hard work, we got this as 0.31 meter here. Then what would be the value of H here? Any one of you? So simple to understand now, right? So this is the way how we do the calculation here. What would be the value of H here now? The value of H is out of 0.72. Now we have to subtract 0.31. So the rest of value what is left here to you is H is equal to 0.41 meter here. Clear? That's the final answer for you. So therefore, what would be the correct answer here? 0.41 meter, right? So approximately we can take, because obviously every calculation it is not in GATE also, there will be 2 decimals approximation will be there. So with that approximation, I can go with the second option, that is option B, because we know that the final answer is 0.41 meter, which is very close to this one. You may argue with me, sir, I will go with the none of the option. As I am saying again and again, you will be provided the approximation of 2 decimals. Clear? So in the GATE examination, final GATE examination, keeping that in the mind, I can satisfy. In fact, I can go with the option B without any doubt. So if you have any doubts, you are requested to ask or keep the doubts in the comment section, so that I will go into answer it. Now let me go with the second question, statement of the second question. Look at the statement of the second question, every one of you, right? So this is the differential pressure gauge level measurement. Let me explain the statement of the question once again. So every one of you, please read the statement of the question first. And the statement of the question is given as a level measuring system employing the differential pressure method. This is the interesting method which is used to measure the height, right, or else the level, with a strain gauge pressure sensor, fine, is used to measure the level of a liquid within the range of 0 meter to 1 meter. This is the full range. Clear? So is an open tank as shown in the figure. Good. The level transmitter output should be current signal in the range of 4 milliampere to 20 milliampere. Good. If the reading of the level transmitter is 16 milliampere, then the level in the meter is dash. See, of course, you may not be required to know the overall operation to solve this question, because with the basic mathematics we can answer this question. See, what they are saying is, of course, this is the outlet pressure here. So let us say outlet pipe. We are having the tank here, and the water level can be from 0 meter to 1 meter. And that is a variation, it is possible anywhere in between 0 to 1 meter. That is the meaning of that. That means the minimum water level what we can expect here is 0 meter, and the maximum water level what we can expect here is 1 meter. So these things are very easy and quite understandable, isn't it? So now let me explain a simple question here. So as we know that it is a level transmitter or the differential pressure transmitter, what should I say here? First of all, let me say all the way this as a level transmitter. What is the meaning of that transmitter? Transmitter means whatever may be the input signal, finally it will deliver the output as a standard current. So here the water level is the input and the current is going to be the output. Simple. Current is going to be the output. Now look at that. What is the range of the water level? It is going to be 0 meter to all the way up to 1 meter. Correct? So this is also very simple to understand. 0 meter to 1 meter. What is the standard current range here? 4 milliampere to 20 milliampere. Now those students who want to know clearly about how the transmitter functions, what is the reason why we will keep 4 milliampere to 20 milliampere standard current range, if you have any doubts related to this particular topic, you can refer my lectures, recorded lectures in BYJU'S Exam Prep app. Just download the BYJU'S Exam Prep and go to instrumentation lectures. There you can find the recorded lectures of my subject, and in fact I have explained each and every minute concept in a very detailed way. There you can find what is the meaning of transmitter and what is the range of the current, why do we fix that range of the current, and what happens if the range of current is not matched with the industrial standards. All these things I have discussed so elaborately. Clear? So now let me go with the statement of the question here. As you can see here, water level let me write down here and the current let me write down here. Those who has the minimum common sense, they can understand that if the water level is 0 meter, it has to release 4 milliampere current here. Clear? It is a live zero, so it will be 4 milliampere current. And similarly, we can understand very clearly immediately, that is 1 meter water level if you have, how much current you should get? It should be 20 milliampere current, right? So 0 meter to 1 meter, it has to be taken into 4 intervals. Let me take like that. So let me take for 2.5 meter here, and after that 5 meter here, after that 7.5 meter here. Clear? I hope these things are clear to you, right? So 2.5 meter, so what would be the expected value? And 5 meter and again 7.5 meter. As we know that the slope remains linear here, slope is constant. Naveen Kumar, good evening, right? So as the slope is constant, what can I say here? You have made the 4 intervals for the water level from 0 to 1 meter. Similarly, you have to make 4 intervals from 4 to 20 milliampere. Therefore, if you make it clearly, I can say it must be written as 8 milliampere and then 12 milliampere and then 16 milliampere for 7.5. Clear? So this is the only possibility we will be getting. Otherwise, you can form the straight line equation between the current and water level and then substitute the water level is equal to 7.5, you will going to get 16 milliampere. So the straight answer for this question is, if you want to get 16 milliampere current, then the water level must be equal to how much? 7.5 meters here. Clear? It's very easy question, as I was saying, 7.5 meter here. That's the overall idea here. Clear? So water level, when it reaches to 7.5 meter, this total transmitter will going to release 16 milliampere current. Very easy. And again, you look at that. What is the sensitivity here? Can you look at and tell me here? Every time when the water changes here, when the water level changes, it is changing by, so if the water level changes by 2.5 meter, if the water level changes by 2.5 meter, then the current will going to change by 4 milliampere, right? So there are around so many students that are in the live, right? So you have to answer to me regularly. Then only I will going to get energy and I will give back it to you, right? So I can say 2.5, every 2.5 milliampere change in the current. If the delta I is equal to 2.5 milliampere, then this leads to, sorry, one second, this is delta H, I am extremely sorry. If the delta H, that means change in the water level is 2.5, delta H 2.5 meters here, then we will get the change in current as 4 milliampere. This is a wonderful statement, isn't it? So likewise, if you can see here 0 to 2.5, it is 2.5 meter change. So the current is changing from 4 milliampere to 8 milliampere. Similarly, 2.5 to 5, another 4 milliampere is the change. So net it will become 12 milliampere. Likewise, it will keep on progressing till we reach to 1 meter here, where we can find 20 milliampere current at the other side here. Clear? Now, let me show you the other question. In fact, this question is framed based on the perfect working of the differential pressure transmitter. So let me tell you here. So how does this differential pressure gauge works here? So in a simple way, we will take the pressure tapping here. So let me take pressure tapping here. Pressure tapping here. So let us call this as a P2 here. The pressure at this point is P2, and let me say the pressure at this point as P1 here. Clear? So if you take these two pressure tappings or these two pressure readings and subtract that, then what we will going to get here? Or else first of all, can you say what is P2 here? Simple. P2 is at the bottom here, almost at the bottom. So we all can easily understand and apply our basics. This is the total height and vertical height of the liquid column here. Correct? So this much amount of the liquid is there in the tank which has a height of H. So what would be the pressure as P2 here now? So the pressure at P2 or the pressure at the second point can be written now as successfully the pressure at 1 plus rho into G into H. So the density of the fluid. Let me write down like this. Simple. So then we can even write down this as a P2 minus P1 all the way, which is generally called as a differential pressure delta P. Correct? Delta P, and it must be written so successfully as rho F into G into H. Right? Now look at what is given here. So it was given like what is the approximate differential pressure that the level transmitter measures. Right? So it is assumed that liquid density and all these things are given. Now look at the beauty of this. When the what is at 7.5 meter, we all know that it is giving 16 milliampere current. Right? So now I will ask a question to you, all of you. So now as the question is saying in this previous question that current generated is 16 milliampere by the transmitter, without any second thought, I can say the current generated is 16 milliampere. When the current generated is 16 milliampere by the transmitter, we know that the water level is going to be 7.5 meter. That means moving forward to the next question on the same data, that means this question also follows the previous data only. So I can say H is going to be equal to 7.5 meter here. So rest of everything we know. So that means the differential pressure delta P now, we can say density of the fluid is 950 and G is 9.81, right? So G is given like 9.81, I'm sorry. Right? So let me say G is going to be 9.81 here and multiplied by what is the value of H? H is 7.5. Now if you multiply all these things, what would be the delta P? Can anybody say? Can anybody give the answer for this? What would be the delta P value? 950. Naveen, any answer from your side? Rashekar, take your calculator and make it very easily. This is simple calculation. 9.81 into 7.5. So what would be the value here? of course you are going to get almost 70 kilopascals. This is an approximate value. 70 kilopascals you are going to get, final answer. So therefore, if you look at the statement of the question also, it was asked that what is the approximate differential pressure. So what would be the correct answer? Option A is the correct answer for this question. Now what you must understand is pressure calculation and the level calculation both can be correlated. That means if you know what is the differential pressure value here, we can estimate the value of the water level or the level of the liquid inside the tank here, correct? If you know differential pressure, you can also estimate the value of level. That is why I say that most of the time the pressure, flow rate and level, all these things are interconnected to each other. Being an engineer, you should know how to play with all these things and how to use this in an application oriented. Clear? Now moving ahead to the next question. So the next question seems to be easy question, but anyway I have to explain this, right? So the pressure in a vacuum chamber, okay, is measured by a vacuum gauge. So that means we are having a vacuum gauge to measure the vacuum pressure. Good. What is the absolute pressure if the atmospheric pressure is 101325 Pascal? So what is the relation between absolute pressure and gauge pressure, first of all? So I hope every one of you know that is absolute pressure can be always given as equal to atmospheric pressure, that is P ATM, plus P gauge pressure. Clear? So let me write down P gauge pressure here, right? So if anyone is so interested to know how this formula came and what is the logic behind this and a clear conceptual detailed explanation, I request once again, please go to the recorded lectures by downloading the BYJU'S Exam Prep app. There you can find my recorded lectures. Go to the chapter called pressure measurement and see the concepts called basics and pressure conversion and all these things, right? So I have explained each and every minute details so clearly in the recorded lectures, right? So now you can understand what is the atmospheric pressure. Find 101325 Pascal. Good. And what about the gauge pressure? Gauge pressure was given like 45 Pascal. Clear? So if I write gauge pressure as a 45 Pascals here, fine, nobody will going to obstruct me. But should I take minus or plus here? Simple answer, minus or plus. Even though your gauge pressure indicated value is 45 Pascal, when you are calculating the absolute pressure, we have to take this as a minus as we are sensing the vacuum pressure. Clear? Vacuum gauge. Why so? Because absolute pressure should come less than atmospheric pressure when we are dealing with the vacuum. Clear? So that means if you look at the absolute pressure, what is the final value you will be getting here? Any idea? So absolute pressure is this minus 45. So 45, if you subtract this, it will be very easy calculation only. So right, 15 I think, right, just yes, so 25, yes, 25 minus 45, right? So it is going to be 101280, right? So this is simple calculation. I feel everybody of you can do that, correct? So this is the absolute pressure we are getting. Now naturally you must understand the fact that whenever we are dealing with the calculation of pressure measurement, especially like vacuum gauge, the fundamental point that should be there in your mind, sir, tank height is 1 meter. Guru Bharan, where is 1 meter here? Oh, you are there in the starting. This one or which question? So we take 0.72. Where? Which question? Suddenly you came and asked some question, Guru Bharan, please tell me which question you are speaking about so that I will understand that in the better way. Okay? Right. So now you can see here all the way 101280 Pascal is the value what we will get for absolute pressure. As I was saying to you, absolute pressure must come less than, absolute pressure must be less than the value of the atmospheric pressure when we are dealing with the vacuum gauge measurement or vacuum measurement, right? So therefore, what should I conclude here? Ultimately is, look at that. Absolute pressure should be less than atmospheric pressure. This value you can get only if you take gauge pressure as a negative value. That's why I always say to every student that when you are dealing with the vacuum, even though they mention like 45 Pascals, you must consider that as a minus 45 in your calculation. Then only you can satisfy this particular expression. Clear? So Guru is asking some questions. The total height of the tank is 1 meter. No. It's not total height of the tank here. From 0 to 1 meter. Total height of the tank may be so much. That doesn't matter for us. But we are using the transmitter connection only for 0 to 1 meter. Clear? So 0 to 1 meter is the range what we are using, but the tank height might be so much. Clear? Tank height may be so much. It may be 1.5 meter or 10 meters or 2 meters, doesn't matter for us. Clear? So I hope Guru you got the idea or you got the answer. If you are not clear with the statement, once again please mention to me, I will explain that. Don't worry about that. Right? So this question is completed. Now moving ahead to the statement of the next question here. So the next question statement is, a submarine is at a depth of D below the ocean surface, right? I think ocean density of the seawater is 1025 kilogram per meter cube and 1 atmospheric pressure is equal to, of course, 1.013. Yes. Okay, thank you, Guru. Very good. So 101325 into 10 to the power of 5 Pascal. The pressure gauge, the gauge pressure attached to the submarine reads, that means this is the value of the gauge pressure. Clear? Because the submarine, the gauge which is attached to the submarine to measure the gauge pressure, it is sensing the value or it is showing the value of 1.12 into 10 to the power of 7 Pascal. Good. The depth of the submarine is dash. See, these kind of questions are very simple. The only thing is you need to know the basics clearly, right? So now look at that. Suppose if I say the atmospheric pressure is this. Assume that this is the sea level. Okay. So let us say this is sea level, and you can consider that this is above the sea level and this is below the sea level. Clear? Below the sea level. Now the most important and interesting point here is the pressure which will be acting here all the way is the atmospheric pressure. Every one of you very much clear about that, right? And assume that the submarine is, I hope you all people might be aware of what is the meaning of submarine, right? So it is a warship, right? So assume that we are having the water here all the way. So this is the water, and we can all say that the submarine is at the depth of D here. Clear? Now if you want to calculate the pressure at this point, so pressure at this point, let me say the absolute pressure or PM. So PM is the absolute pressure here. Clear? That should be equal to, how can I write this one? Atmospheric pressure plus gauge pressure here. Clear? So that means the gauge pressure indication would be written as, P gauge would be written as, again, how you will going to get the gauge pressure here? Gauge pressure is always because of the liquid that is present above the submarine, apart from atmospheric pressure, correct? So that can be simple to write, that is the density of the fluid rho f into the gravitational constant, that is acceleration due to gravity g, into whatever the depth it is having here, because h above the submarine, the height of the liquid column is nothing but the d itself, correct? So instead of writing h, we can even write down this as a d also. There is no issue with all, right? So let me write down this as simply like d here. Now the delta, in fact the gauge pressure is given to you. You need not to work too much here because the things are very clearly mentioned here. So what is the value of the density here? Is the density is given here. So please look at all of you. Guru, tell me, is the density is given? Have you got the answer, Guru? So simple. First of all, the density of the liquid here, what is the value of the density of the fluid? Seawater is given like 1025, good, and G is 9.81, and we don't know what is the value of the depth here. That means this D we don't know. So let us calculate that. Don't worry about that. What is the gauge pressure here? Gauge pressure is 1.12 into 10 to the power of 7. Why I am taking that as a gauge pressure? Because it's mentioned that this is the reading shown by the pressure gauge. Clear? So pressure gauge. So the pressure gauge is attached to the submarine, correct? So therefore, if I use that basic here, without any second thought, I can say 1.12 into 10 to the power of 7 Pascal here, correct? So, and whenever you are dealing with the pressure measurement, you should be very confident and clear about the units what you are taking here. Most of the students, they commit the mistake while they are calculating the units or converting the units. So what is the value of D here now? D can be written as 1.12 into 10 to the power of 7 particularly, divided by 1025 into 9.81 here. Clear? So therefore, let me write down the value of D here. If you calculate it, please let me know the answer. 1.12 divided by 1025 into 9.81 here. So all put together, how much you will be getting? 1.13 into, let me write down 1.1138. Okay, of course, a lot of values there, into 10 to the power of 3. That is what you will be getting. So therefore, I can say D is equal to, of course, this is going to be 10 to the power of 3. You will be having, right? It is not actually the meters. it is meters. So therefore I can say 1.11 kilometers approximately. Clear? 1.11 kilometer is going to be your final answer for this particular question. That is the depth. What is you can expect. This is the depth at which the submarine is actually flowing or moving under the sea water. Clear? 1.11. Very good, Guru. Congratulations. Good. Nice. That is not a difficult question, but this is the way how the questions will be, right? So where you have to use your basics. In the same question, if I ask what is the total absolute pressure, how can I write the absolute pressure? Now we have to add the atmospheric pressure. How much that is atmospheric pressure? 1.0. One second. 1.01235, right? So 1.01. In fact, I should write down this. 1.10. Otherwise, we can remove that and keep it very easily. So let me make it clearly here. So this is simply like 1.0132. 1.01325 into 10 to the power of 5. That is the atmospheric pressure plus what is the gas pressure here? Gas pressure is 1.12 into 10 to the power of 7 Pascal. So you must be very clear about the question. What they are asking. If they are asking only about the absolute pressure, then this is what you need to calculate. If they are speaking about only the differential pressure, then we need to calculate only gas pressure here. Somebody is asking some question. Sir, when you will be taking EC and EC related? Yes, Hritik, I will be taking on 13th. 13th of October, we will be meeting. 13th and 14th, after this subject, maybe tomorrow onwards, right? Not tomorrow, maybe Monday, I am expecting, or else maybe from Wednesday, we will be dealing only EC and electrical topic. Don't worry about that, right? So electrical students want me and EC students also want me, right? I will dedicate it because there is no much content is available for instrumentation students. That's why I come on to the live in YouTube to take the classes on for instrumentation students. Definitely once it is done within 3-4 days, maximum 2 to 3 days, I will go and dedicate myself to the EC classes. However, the syllabus is mostly common for EC and electrical students also, right? So instrumentation students especially. So the barometer shown in the figure contains the mercury which has a density of this much, right? So good. If the local atmospheric pressure is 100 kilopascal and G is 9.81 meter per second square, the height of the mercury column L in mm of Hg is dash. See, this is a simple question. I personally believe that being an engineering student, you might have done barometer experiments in your school days, right? So what it is, so we will be having a capillary pipe here where the liquid is all the way, manometer liquid is filled up to here, A to B. Correct? So when we turn this and dip this, right? So slowly what will going to happen? Manometer liquid all the way it will come down, right? So it will come down and come down and come down. So let us say the manometer liquid all the way come up to down and it stopped at exactly this point, right? When it stops at this point, this is considered as a reading on the manometer, correct? Only this is considered as the reading on the manometer because the manometer liquid came all the way up to here and stopped at this point. Now tell me why it will going to stop here? It will stop here. The reason is, if you look at clearly, right? So let us assume that the pressure, absolute pressure at B, point B, let me say absolute pressure at point B should be equal to the atmospheric pressure. Then only we can say clearly that if this happens, right? So sir, what subjects are going to take in the YouTube? Control systems for EC and electrical students, sometimes even circuit theory also, and measurements for electrical and instrumentation students. I repeat, control system and circuit theory for EC and electrical and instrumentation students. Apart from that, measurements and instrumentation only for electrical and instrumentation students. Clear? These are the subjects I used to handle. Now, every one of you must understand whatever the pressure the liquid is possessing or the manometer liquid is possessing exactly at this point, this must be equal to atmospheric pressure, correct? Then only I should say if these two sides pressure is same, then the liquid will not move here from the capillary to the bowl here. It will stop moving, right? So that time, if you look at the reading here, all the way you may be finding the height or the L is the reading that is available on the manometer liquid here. Clear? When it will going to stop here? All the way it is down, means it is actually coming down up to here and stops at this value. Why it is stopping at this value? Because by the time when the liquid all the way displaces like this, at this point you must understand all the way the pressure what is exerted here, that will be equal to the atmospheric pressure. Clear? So what is PB here now? So simple. PB is rho F, manometer liquid density, into G into H, right? And that should be equal to atmospheric pressure. And atmospheric pressure is given here? No. We need to actually, yes, the barometer shown in the mercury, if the total atmospheric pressure is, yes, 100 kilopascal, it is given in the statement of the question, correct? So therefore, the density of the fluid is given and acceleration due to gravity, you know, and what is the H here? Now H is not this H, I am extremely sorry. The reading of the manometer liquid, which you can see here, of course this should be taken as L here, clear? So this should be L, simple. And this calculation must be equal to 100 kilopascals. Let me write down 100 into 10 to the power of 3, right? So from this calculate the value of L, right? And while you are doing the density calculation, please look at that it is mentioned in grams per centimeter cube. You have to convert this into kilogram per meter cube, clear? Kilogram per meter cube, be clear about that one, clear? So after converting that, use that here so that you will get the value of L. So 99% I have done the question. You require to do simple algebra here and do this as a homework once I complete this class, right? So you can keep the solution or keep your answer in the comment section, clear? So because as you know, every day I will give at least 1 or 2 questions as a homework to you, right? So my sincere suggestion is, if you are seriously and sincerely preparing for the GATE examination, it is your responsibility to solve and do more number of practice questions. In fact, I am not going to write the exam, you are going to write the exam, correct? So therefore, put your pen down on the paper, use your calculator. Already 99% I have solved it and I am leaving algebra to you. Use that and get it done and keep your answer in the comment section. Don't forget this, clear? So now let's move on to the statement of the next question. Next question is very simple. I think it's very easy for everyone. A Pirani gauge is a sensor which is used to measure the pressure of the order dash. So you all know that Pirani gauge is a low pressure gauge, correct? So this is going to be low pressure gauge, right? Low pressure gauge, of course. If you take low pressure gauge, it will going to measure the low pressure. So out of these 4 options, which is considered as a low pressure, 100 megapascal, definitely it is not the low pressure. Nobody can agree with that fact. And even 1 megapascal also, no, it is not low pressure. Now there is a tough competition between 100 pascal and 1 pascal. Those students who attended my classes, they already know this concept that this Pirani gauge can measure the pressure in the order of pascals, which is very low pressure. And if you want to know the range of different sensors, of course, I have given a beautiful chart here. You can go through the ranges measured by each and every gauge. And I should say clearly that this Pirani gauge, McLeod gauge, and even thermocouple gauge, there are several things, right? So ionization gauge is the gauge which is capable of measuring a very low pressure up to 10 power minus 8 mm of Hg, such a low value, right? Or 10 power minus 6 pascals. Newton per meter square, we can call that as a pascal here, clear? Either Newton per meter square or the unit can be pascal. So there are several low pressure gauges, starts from ionization gauge and Pirani gauge, McLeod gauge, clear? Ionization gauge is a gauge which can measure the very low pressure, damn low pressure. And most importantly, Pirani gauge is the one which will work on the thermal conductivity of the gas at low temperatures. And McLeod gauge is considered as a reference gauge, clear? McLeod gauge is used for the calibration purpose. Of course, that is not our discussion of the question. Our discussion is just to say what is the range here. Why I have given this simple question? Because I myself found that almost around 5 to 6 times this question in the previous year question papers. So you need not to remember the range of the sensor, but you should know at least the basics related to Pirani gauge, right? So you can eliminate this. If it is like a numerically answered question, or if they give fill in the blank, then you require to enter the answer. So it is advisable to know these things. Even if you can't remember, if you practice well enough many times, then automatically these things will go into your mind, clear? So moving ahead to the next question here. So let me move it to the second, of course. This is the last question I would like to say, right? So the question is, a McLeod gauge is available which has a volume of the bulb nearly equal to 150 centimeter cube and the capillary diameter is 0.3 mm here, right? The gauge reading for a low pressure of 30 into 10 power minus 6 meter is dash. Have you seen here? The pressure unit is meters. That is the magic of the McLeod gauge, clear? In McLeod gauge, the pressure reading will be in meters. So we all know that McLeod gauge can be used to measure the low pressure of the gas. So low pressure equation can be given as the area of cross section of the capillary tube AT into the reading of the the reading on the meter. So whatever the reading you are going to see here, H, right? So this reading, the whichever is visible on the scale, right? So the final reading, what should I say? And this reading is actually the compressed height, right? So H square divided by the volume of the bulb. This is considered as the approximated formula for the low pressure measurement, especially in McLeod gas. You may ask a simple question, sir, what is this, sir? Directly you are writing the formula here. As I was saying, this is champion series. We are about to discuss only the questions, right? And if anybody is so much interested to know how this formula came, what is the background of this, what was the principle of McLeod gas, and what is the working of McLeod gas, once again I am suggesting you, please go through the recorded lectures of BYJU'S Exam Prep. Download the BYJU'S Exam Prep app. There you can find my recorded lectures of industrial instrumentation, and in that each and every topic was explained in detail, including McLeod gauge also in the low pressure measurement. Clear? So anyway, if you use the basics here, what will be the low pressure here now? So the low pressure could be written as AT. How can I write AT? AT is considered as the area of cross section of the capillary tube. Now this is a circular cross section here. So let me take up here. Here we are having the capillary tube. So it is going to be having the diameter D here. So let us say this is the capillary area of cross section, correct? So therefore I can say AT could be written as a pi by 4, simple, pi by 4 into diameter. What is the diameter here? 0.3 meters square, good, into H square. We don't know what is the value of H. In fact, we need to find out that reading, good, divided by, what else is the value here? VB, volume of the bulb. Volume of the bulb is given like 150 centimeter cube. So let me write down 150 into 10 to the power of minus 2, right, whole cube, minus 2 whole cube. This is what we need to write down, clear? So that means 10 power minus 6 it is going to be, clear? So here the low pressure, as I said, this is the value of the low pressure. Be clear about this one, okay? So therefore let me write down the low pressure value here as 30 into 10 to the power of minus 6 here, and right hand side you will be having like pi by 4 into 0.3 whole square into H square all the way divided by 150 into 10 to the power of minus 6 here, clear? So this is a very sufficient information for this particular question, I feel that, and you require to calculate only the value of H out of all these things. So use all these basics, because everything I have explained. I'm extremely sorry, 0.3 mm it is going to be. So here 0.3 mm when you write, what you will going to get? 0.3 mm. So 0.3 into 10 to the power of minus 3 whole square into H square. So of course here also we should do. So let me do it here. This will be 0.3 into 10 to the power of minus 3 whole square into H square. Of course, we are almost at 99%. Again, it is you have to put your pen on the paper and do the calculation, and from this calculate the value of H. See, I am not like a teacher who will do like a spoon feeding to you. You all are engineering students, right? So you have to work from yourself. You have to work by yourself. In fact, you have to be fast compared to me, right? So I sincerely advise every one of you, use your calculator and pen and paper and put it on the paper and solve and keep your answer in the comment section once the section is completed. Clear? I will definitely review the solutions, and once you solve this you will going to get the H. As I was repeatedly saying that those students who are very interested to know how this formula comes into the picture, what is the background of that, please go to the lectures in BYJU'S Exam Prep app. There you will be finding this. If anyone is getting difficulty to understand the McLeod gauge, you can put it in the comment section, and I will going to take a separate session only on the McLeod gauge. Clear? So moving ahead to the last question, this is definitely, it is going to be the homework to you, right? So this is homework. This complete question is homework, because I have not given up to now a single question for homework. You all can read the statement of the question, understand the statement of the question here, because this same concept I have even discussed in the YouTube session also. How we will use the bubbler, right? How we will use the bubbler to measure the liquid depth or else the liquid level. So if you want to understand how we use the bubbler, right? Bubbler to measure the liquid level, please go back to my previous lectures in the YouTube. There you will get the concept, or you can see the recorded lectures in BEP app. Finally, you will understand what is the concept of bubbler. And it is you have to practice this, because I am giving a single question, single full question as a homework to you. And get it done from your side and keep your answer in comment section. I sincerely advise every one of you take homework so seriously and sincerely. Of course, those students who are very sincere, they are messaging me personally, but I advise you, please keep in the comment section so that the other students also will get the good motivation, and even I will also get motivation, isn't it? Because the more and more students are solving this, then I will understand that I will come up with the great questions again. Clear? So with this, I have done the champion series, especially in industrial instrumentation subject. As you all can see, 4 different lectures I have taken on the different topics, and of course most of the important topics are covered in industrial instrumentation. If you are interested to connect to me through the Telegram channel, you can use any of these credentials to connect to me. Right, Dasari is asking some question. Good evening. Good evening, Dasari. Almost we are about to complete the section, right? So you can use this credential to get connected to me through the Telegram link. As I was repeatedly saying, being an engineer, you should not be lazy and you should not expect the spoon feeding. You should only learn the concepts from the faculty, and you should come up from your side and put your pen on the paper and do every calculation from your side. In other way, your accuracy as well as speed of doing the calculation also will improve only when you practice more and more questions every time. Clear? Hope you really enjoyed all the sessions of the champion series, especially in industrial instrumentation subject, and we will come up with a new subject related to optical instrumentation in upcoming sessions. Thank you very much.